All right, listener. So you're a 16-year-old thinking about taking SQA, higher graphic communication, but maybe you're wondering about the CAD modeling side of things.
Like, what exactly do you need to know to ace this part of the course?
Well, we've got you covered.
We've been poring over the SQA course reports, the marking instructions, even some helpful YouTube videos from Scottish teachers.
All to break it down for you. Think of us as your wee study guides for higher graphic communication.
Exactly.
Now, you might be thinking higher graphic communication.
That's just drawing fancy pictures, right? That's where you'd be wrong.
Uh-huh.
It's about communicating ideas clearly and effectively.
Okay.
It's about using industry standard software and techniques to design and model the world around us.
Uh-huh.
And a massive part of that is CAD modeling.
That's right. We're talking about bringing your ideas to life in 3 dimensions.
It's designing products, buildings, even entire virtual worlds.
Wow.
And if you've done National 5, you'll already have a good grasp of the basics. But higher graphic communication takes things up a notch.
Okay.
It's a bit like going from building with Lego to designing and building a skyscraper.
Yeah.
You need a deeper understanding of the tools, the techniques, and the design process as a whole.
So where do we even begin?
Well, before you can conquer the 3D world,
Uh-huh.
you need to become a master of the 2D universe.
Okay.
Just like a good architect starts with a solid blueprint, a good CAD modeler starts with precise and well-structured 2D sketches.
Right. So what are these essential 2D tools we need to have in our arsenal?
You'll need to be fluent with your lines, circles, rectangles, ellipses, all the building blocks of 2D drawing.
Mm-hmm.
And then there are the tools that let you manipulate these shapes, like trim,
Okay.
which lets you precisely cut lines and shapes to your exact specifications.
So that's useful.
And let me tell you, trim is a lifesaver, especially when you start working with more complex designs.
I can imagine. What about when you need to repeat elements in a design? Do we need to draw them over and over again?
Not at all. That's where the array tool comes in, linear box and radial arrays. They let you repeat elements in a straight line, a grid pattern, or even a circular pattern.
Wow.
It's a massive time saver.
I bet.
And it ensures that all those repeated elements are perfectly spaced and aligned.
Right.
And then you've got your offset mirror project geometry tools, all essential for creating accurate and symmetrical designs.
So it's all about precision in 2D.
Yes.
That makes sense.
Mm-hmm.
But what about bringing these designs to life? How do we make the leap to 3D?
Now we're getting to the fun part.
Okay.
This is where those 2D sketches take on a whole new dimension, literally.
Uh-huh.
We're talking about tools like Extrude, which lets you take a 2D shape and give it height, turning it into a 3D object.
Right.
Think about designing a simple mug.
Okay.
You'd sketch the outline of the mug in 2D, and then use Extrude to give it depth, transforming it into a 3D model.
So it's like stretching that flat shape upwards to create a solid form.
Exactly.
That's pretty cool.
Oh.
What other tricks do we have up our sleeves?
Well, if Extrude is about stretching, then Revolve is about spinning.
Okay.
Imagine taking that same mug outline and spinning it around a central axis.
Huh?
Boom, you've got a perfectly cylindrical mug.
Nice.
It's like magic.
It does sound like magic. And what about those fancy curves and transitions between shapes? How do we create those in 3D?
For that, you'll need to master the art of the loft tool.
Okay.
Imagine taking 2 different 2D shapes, say a square and a circle, and smoothly transitioning between them in 3D space.
Right.
You'd use the loft tool to create that smooth flowing connection, creating a unique 3D form.
It's like morphing one shape into another.
Yeah.
I can see how that would be useful for designing all sorts of things.
Absolutely.
And I remember from National 5 using the coil tool to create springs and spiral shapes.
That's right, but in higher graphic communication, it's called helix.
Right.
A slightly fancier term for the same cool tool.
Helix got it. Are there any other 3D tools we need to know about?
One of the big ones in higher is extrude along a path.
Okay.
You'll be using that a lot as it lets you extrude a 2D shape along a predefined path, creating all sorts of intricate and complex 3D forms.
Wow.
Think about designing the handrail for a spiral staircase. You'd sketch the profile of the handrail in 2D and then use extrude along a path following the spiral of the staircase to create the 3D handrail.
That's amazing.
It's a powerful tool for creating anything from curved furniture to organic shapes inspired by nature.
It sounds like we can create pretty much anything with these tools.
You're absolutely right.
Okay.
But even the best CAD modelers make mistakes.
Oh, no.
Don't worry, though, because that's where the editing tools come in.
Okay, I'm all ears.
All right.
What kind of editing magic can we perform?
Well, let's say you've modeled a water bottle, but it's solid all the way through.
Uh-huh.
You don't want to waste material printing a solid bottle, right?
No.
That's where the shell tool comes in. It
Okay.
lets you hollow out your 3D model, creating a thin-walled shell, just like a real water bottle.
Oh, right. So instead of modeling the inside and outside separately,
Aye.
you can just make it hollow.
Exactly.
That makes a lot of sense.
It does.
What about smoothing out those sharp edges? I'm guessing there's a tool for that too.
You bet there is.
Okay.
It's called fillet, and it's every CAD modeler's best friend.
Right.
You can use it to create smooth, rounded edges, getting rid of those sharp corners. And it's not just for simple curves either.
Ooh.
You can have regular fillets, which create a uniform curve along an edge, or irregular fillets, which let you vary the radius of the fillet along the edge.
Ooh, irregular fillet sounds fancy.
They are quite fancy.
I'm guessing that gives you more design flexibility.
Absolutely. It lets you create those sleek, ergonomic curves that make products look and feel so good.
Yeah.
And then, of course, there's the chamfer tool, which is similar to fillet.
Right.
But instead of a rounded edge, you get a slanted edge.
Okay.
Again, you can have regular and irregular chamfers, giving you loads of options for creating professional-looking models.
So many ways to refine our 3D masterpieces.
There are.
But what about when we need to create symmetrical objects? Surely we don't have to model each side individually.
That would be a nightmare. That's where the mirror tool comes in. It lets you create a mirror image of any part of your model, instantly creating a symmetrical design.
Very handy.
It's a lifesaver for anything from chairs and tables to car parts and machine components.
Speaking of repeating elements, do those array tools we talked about in 2D work in the 3D world as well?
Absolutely. 3D arrays are even more powerful. They let you repeat features like hole slots or even entire components in a pattern, creating complex geometries with just a few clicks.
Wow.
Think about designing a gear with multiple teeth or a speaker grill with a repeating pattern of holes.
Right.
3D arrays are your secret weapon for creating those intricate designs.
This is all starting to come together.
It is.
So we've got our 2D skills, we've modeled some amazing 3D shapes, and we've even edited them to perfection. But something's missing.
It's time to assemble.
Assemble.
Now that you've learned how to model individual parts, it's time to bring those parts together to create a finished product.
Right.
Think of it like building a complex Lego model, except you're doing it all in the virtual world.
That sounds like a fun challenge.
It is.
But how do we actually connect all these parts together? I'm guessing it's not as simple as dragging and dropping.
You're right. Just like with Lego, there are specific ways to connect the pieces, and that's where 3D constraints come into play.
Okay.
These are the constraints that define the relationships between different parts in an assembly, ensuring that everything fits together perfectly.
So they're like the instructions that tell each part where to go and how to connect to the other parts.
Precisely. The main 3D constraints you'll be working with are mate, align center, axis orientate, offset, and tangent.
Right.
Mate is used to join two surfaces together.
Okay.
Think about connecting the lid to a jar or the base of a chair to the seat.
Right.
Lines up features like edges or faces.
Okay.
While the center axis constraint, well, it aligns things along a central axis.
And what about orientate? How does that constraint work?
Orientate lets you rotate parts into specific positions. Imagine you've modeled a hinge for a door.
Okay.
You'd use the orientate constraint to rotate the hinge into the correct position on the door frame.
Right.
Offset creates a specific distance between two parts, like ensuring that the gap between two moving parts is exactly 2 millimeters.
Okay.
And tangent ensures that two parts touch each other smoothly at a single point, like a ball bearing fitting snugly into a socket. Mastering these assembly techniques is essential for creating complex and functional products.
I can see how these constraints are essential for building anything with moving parts or intricate connections.
Absolutely.
But how do we keep track of all these parts and constraints? It seems like things could get pretty complicated with larger assemblies.
That's where understanding CAD terminology comes into play.
Terminology. It's like learning a secret code for the CAD world.
In a way, it is.
I'm ready to decode some of those key terms.
Excellent. You've already learned about components and assemblies, but what about sub-assemblies?
Sub-assemblies, they sound a bit like assemblies within assemblies.
Spot on. It's a group of components that form a distinct part of the larger assembly.
Okay.
Think about a car engine. The engine itself is an assembly, but it's made up of many smaller sub-assemblies like the pistons, the crankshaft, and the cylinder head.
Right.
Breaking down complex assemblies into smaller sub-assemblies makes them easier to manage and understand.
Okay, so sub-assemblies help us break things down into manageable chunks.
Exactly.
What other terms do we need to know about?
Well, there's the work plane, which is like a virtual drawing board that
Right.
you use to create your 2D sketches.
Right.
It's your starting point for creating any 3D feature.
Okay.
You'll also be working with axes, which are reference lines used for measurements and rotations.
Uh-huh.
They help you to position and orient your features accurately.
And what about the word features? I've heard that one thrown around a lot in the CAD world.
Features are basically the individual elements that make up your 3D model.
Yeah.
You've got your basic features like extrudes, revolves, and lofts, which are the building blocks of 3D modeling.
Right.
And then you've got more complex features that are created by combining or modifying these basic features.
Right. And those 2D shapes we were talking about earlier,
Right.
the ones we use to create those features, those are called profiles, right?
That's right. And when you draw a profile on a work plane,
Uh-huh.
that's called a sketch. It's like the blueprint for your 3D feature.
It's all starting to come back to me now.
Good.
Like pieces of a puzzle fitting together.
Exactly. And just like a puzzle, each piece has its own name and function.
Right.
Remember those faces, edges, and vertices we talked about?
Uh-huh.
Those are all important terms for describing the different parts of a 3D model.
Okay.
A face is a flat surface. An edge is a line where two faces meet. And a vertex is a point where two or more edges meet.
Okay.
Understanding these terms is crucial for communicating your design ideas effectively.
Okay. I think I'm starting to get the hang of this CAD lingo.
Excellent. There are just two more terms I want to highlight.
Okay.
Datum is a reference point used for dimensioning. It's like setting a fixed point on your model that you can measure from.
Right.
And suppress means to temporarily hide a feature in your model tree. This is useful for decluttering your workspace and focusing on specific parts of your design.
There's a lot to remember.
It is.
It feels like I'm learning a whole new language.
It might seem like a lot now, but I promise you it will all become second nature as you work through the course.
Mm-hmm.
The more you use these terms, the more familiar they'll become.
It's like learning any language practice makes perfect.
Exactly. And speaking of practice, we've got some insider tips for you straight from the SQA trenches.
Ooh.
These are the tips that will help you avoid those common mistakes that students often make on the exam and the assignment.
Okay.
Are you ready for some SQA gold?
Absolutely laid on me.
All right.
What are these secret weapons for SQA success?
Let's delve into those SQA examiner reports. They're like a treasure trove of insights helping you learn from other people's mistakes so you can avoid them yourself.
I'm all ears.
Yeah.
What are some of the common pitfalls that students stumble into?
One of the biggest traps is not using the correct terminology.
Right.
Remember all those fancy CAD terms we just discussed?
Right.
Well, the examiners are looking for evidence that you understand those concepts, not just that you can click the right buttons in the software.
So it's not enough to just know how to use the tools we need to be able to explain what they're called, what they do, and why we're using them.
Exactly. Another common mistake is over-reliance on the CAD software.
Right.
It's easy to get caught up in using all the fancy features and forget about the underlying principles of graphic communication.
I can see how that would happen. It's like relying on spell check to write an essay.
Uh-huh.
You might end up with a technically correct document, but it might lack depth and originality.
That's a brilliant analogy. And finally, one of the things that examiners often see is poorly structured models.
What's that mean exactly?
It means that students haven't planned their approach before diving into the modeling process. They just jump in and start creating features without thinking about how the parts will fit together or how the model will be assembled. This can lead to a messy model tree, inconsistent constraints, and a whole lot of headaches down the line.
So it's crucial to have a clear plan of attack before we even open up the CAD software.
Absolutely. Think about the overall shape of the object. Break it down into simpler shapes, and then consider the most efficient way to model those shapes.
Okay.
It's like building a house. You wouldn't start with the roof before laying the foundation.
Right, a solid foundation.
Aye.
That makes sense.
Planning and structure are key to a successful CAD model.
But what about those explain questions in the exam papers? I've heard they can be tricky.
They can be, but they're also a great opportunity to show the examiners that you truly understand the concepts.
Okay.
The key is to go beyond just describing what you did.
Right.
Explain why you chose a particular tool or technique, what its advantages are, and how it contributed to the overall design.
So we need to be able to articulate the why behind the what when it comes to graphic communication techniques.
Exactly.
It's not just about clicking buttons, it's about making informed design choices.
Precisely. And speaking of making informed choices, the SQA course reports also highlight the importance of understanding different modeling approaches like top-down and bottom-up modeling.
Ah, yes, top-down modeling. That's where you
Yep.
start with the overall assembly and then work your way down to the individual components, right?
Exactly. It's a great approach for complex assemblies with lots of interconnecting parts.
Yeah.
You start with the big picture, define the overall structure and relationships between the parts, and then flesh out the details as you go.
Okay.
It's like designing a car. You'd start with the overall chassis, then add the engine, the wheels, and finally the finer details like the headlights and door handles.
And bottom-up modeling is the reverse,
Hmm.
right? You start with the individual parts and then assemble them into the final product.
So, right, bottom-up modeling is more suitable for simpler designs or when you already have existing components that you want to incorporate into a new assembly.
Right.
It's like building a Lego model. You start with individual bricks and connect them together to create the final structure.
So it's all about choosing the right approach for the job, top-down for complex assemblies, bottom-up for simpler designs, or when using existing components.
Exactly.
I'm adding that to my mental toolbox of CAD knowledge.
Excellent. Now let's talk a bit about the assignment. The examiner's reports consistently praise candidates for their performance in the 3D CAD modeling tasks,
Uh-huh.
but there's always room for improvement, wouldn't you say?
Absolutely. There's always something we can learn and improve upon. What are some areas where students could really shine?
I think one of the biggest challenges with the assignment is simply managing our time effectively.
Yeah.
There's a lot to do, and it's easy to get overwhelmed.
You're absolutely right. Time management is crucial for success in the higher graphic communication assignment.
It is.
Break down the project into smaller, more manageable tasks and create a realistic timeline for completing each task.
It's like training for a marathon. You wouldn't try to run the whole distance on the first day.
Right.
You'd break it down into smaller training runs, gradually building up your stamina and endurance.
That's a fantastic analogy.
And don't forget to factor in time for research experimentation and revisions. The design process is iterative, and you'll likely go through several versions of your design before arriving at the final product.
So plan ahead, break down the task, and don't be afraid to revisit and refine your work as you go. Solid advice.
Now, while we're on the topic of the assignment, there's one more thing I want to emphasize.
Okay, lay it on me. What's this crucial piece of the puzzle?
Documentation.
Documentation.
Don't just focus on creating the final product. Document your design process every step of the way.
What do you mean by documentation? Should we be writing essays about our design choices?
Not essays, but think of it as a visual diary of your design journey. Take screenshots of your CAD models at different stages, annotate them with your thoughts and decisions, sketch out your ideas, brainstorm different concepts, and capture your research process.
So it's about showing the examiners how we arrived at the final design, not just presenting them with the finished product.
Exactly.
It's about showcasing our thought process and demonstrating our problem-solving skills.
Think of it as a behind-the-scenes look at your creative process.
Right.
It adds depth and context to your work and shows the examiners that you've engaged with the design process in a thoughtful and deliberate way. And let me tell you, examiners love to see that.
Okay.
It demonstrates a deeper understanding of the subject matter and a commitment to excellence.
Okay, documentation check. I'm adding that to my SQA survival guide. There's one more aspect of CAD modeling that we haven't touched on yet. Something that can really take your designs to the next level.
I bet I can guess what you're thinking. Rendering?
You read my mind.
Yeah.
It's like taking those raw 3D models and transforming them into photorealistic masterpieces. It's the digital equivalent of dressing them up for a photo shoot.
Exactly. Rendering breathes life into your designs, adding materials, textures, lighting, and shadows, creating visuals that jump off the screen. It's an essential skill for anyone serious about product design animation or any field that uses 3D modeling.
I can imagine a client being blown away by a beautifully rendered image of a product that doesn't even exist yet. It's a powerful way to communicate ideas and bring visions to life.
Absolutely. And thankfully, there are some fantastic rendering software packages out there, even for beginners. One that comes to mind is Keyshot.
Hi.
It's known for being user-friendly and capable of producing stunningly realistic renders.
Plus, it's relatively affordable, especially for students. And there are tons of online resources to help you learn the ropes.
Another popular option is V-Ray.
Right.
It's a bit more complex than Keyshot, but packs even more power.
I've heard it's used by professionals in the film and animation industry to create those mind-blowing special effects.
Uh-huh.
It's like the industry gold standard for high-quality rendering.
It is, and for product designers who need those top-notch renders for marketing, V-Ray is a brilliant choice. But no matter which rendering software you choose, there are some key things to remember.
Okay, let's hear those rendering tips.
All right.
What should we be paying attention to?
First off, materials matter.
Okay.
They're the foundation of your render, influencing the look and feel.
So we're talking about things like the texture, the color, how reflective the material is, all those details that add visual richness.
Exactly. Don't be afraid to play around and experiment. The possibilities are endless when it comes to materials, so have fun with it and see what looks best for your design.
Got it. What about lighting that seems pretty crucial for setting the mood and showcasing the details?
Lighting is absolutely key. It can make or break a render.
Right.
A well-lit scene brings out the best in your model, adding depth and realism.
Should we be thinking about different types of lighting, like natural sunlight versus artificial light sources?
Absolutely. Experiment with different types of lighting and see what works best for your scene. Natural light can create a soft, organic feel, while artificial light can be used to create dramatic effects or highlight specific features. And don't forget about the power of shadows.
Or
They add dimension and realism, grounding your model in the scene.
shadows, got it. They're like the unsung heroes of rendering, adding that subtle depth and realism.
Precisely. And remember, rendering can take time, especially with complex scenes. Patience is a virtue, so don't rush the process.
It's like waiting for a cake to bake.
Mm-hmm.
The anticipation makes it taste even better in the end.
I like that analogy. And speaking of taking time, let's talk about another element that can elevate your render-sited environments.
So instead of our model just floating in a white void,
Yeah.
we can place it in a real-world setting, giving it context and making it feel more tangible.
Exactly. Imagine rendering that 3D model of a chair you designed. You could place it in a cozy living room setting, maybe with a fireplace in the background and some books on a nearby table. It instantly helps people visualize how the chair would look in their own homes.
It's like taking your design out for a test drive, showing it off in its natural habitat.
That's a great way to put it. And the good news is that a lot of rendering software packages come with pre-made environments that you can use.
So you don't have to build the entire environment from scratch.
Not unless you want to, of course.
There
There are
are
also websites where you can download free or paid environments.
so many options. It sounds like we have no excuse for not creating some truly impressive renders for our higher graphic communication projects.
Absolutely. It's all about pushing those creative boundaries and showing the examiners what you're capable of. But let's not forget about the practicalities of CAD modeling for the SQA exams.
Right back down to earth for a moment.
Aye.
What are some things students need to keep in mind in terms of hardware and software?
Well, CAD software can be quite demanding on your computer's resources, so you'll need a machine that can handle the workload.
Okay.
We're talking a decent processor, plenty of RAM, and a good graphics card.
It's like having a powerful engine in a car.
Uh-huh.
You need that horsepower to run those demanding applications smoothly.
Exactly. And don't underestimate the importance of storage space. CAD files can get pretty hefty, especially with those complex assemblies. You don't want to run out of space in the middle of a project.
That would be a nightmare. So investing in a good external hard drive or utilizing cloud storage is probably a wise move.
Absolutely. And while we're talking about safeguarding our work, let's not forget about file management.
Right.
A well-organized file system can save you hours of frustration and headaches.
It's like having a tidy desk.
I...
Everything is in its place,
Oh.
and you can find what you need quickly and easily. No more frantic searching through folders.
Exactly. A good file naming system and regular backups are essential. You don't want to lose hours of work because of a computer crash or a corrupted file.
That's the stuff of nightmares, so backup. Cloud storage is a lifesaver in that regard.
It really is. And speaking of lifesavers, let's talk about time management.
Okay.
Those CAD modeling tasks can be time-consuming, so it's crucial to plan your time wisely and break down those projects into smaller, more manageable chunks.
It's like tackling a massive jigsaw puzzle.
Uh-huh.
You wouldn't try to put it together all at once. You'd focus on one section at a time, gradually building up the complete picture.
Precisely, don't try to do everything at once. Set realistic deadlines for yourself and celebrate those small wins along the way. It keeps you motivated and prevents you from feeling overwhelmed.
So true. Celebrate those milestones. And while we're talking about support and encouragement, let's not forget that our teachers are there to guide us along the way.
Absolutely. They're a valuable resource, so don't be afraid to ask for help when you need it. They've been in the SQA trenches themselves and know what it takes to succeed. And beyond that, there's a wealth of online resources available, from tutorials and videos to forums where you can connect with other CAD enthusiasts.
It's like having a whole army of CAD mentors at our fingertips. Thanks for joining us on this exploration of SQA, Higher Graphic Communication. We'll catch you on the next episode of The Deep Dive, where we'll delve into another fascinating topic. Until then, keep designing, keep creating, and keep pushing those boundaries.